In this video, you will be learning about another Python built-in data structure, the list. We have seen that a variable can store a single value or object. So managing hundreds of values means using hundreds of variables with what we learned so far. This is not practical. It would be more convenient to store them in a container in order to retrieve and manipulate them easily. Python provides 4 built-in containers to store multiple values or objects: a list, a tuple, a set, and a dictionary. Each container has its own characteristics and properties. In this video, we'll focus on the list data structure. A list can contain many different types of objects at the same time. You can add and remove elements of a list. A list can have duplicates, and a list is mutable, meaning its content can be modified. A list is commonly represented as a series of contiguous boxes. For example, a list can contain an int, a boolean, a float, and a string, all at the same time. Each box points to an object that is a value at this given position in the list. The list indexing starts at 0. So the first element is at position 0 or index 0. The last element is at position size of the list minus 1. Be careful. In our example, the size of the list is 4, and the position of the last element is at 4 minus 1, which is 3. Let's see how creating a list and manipulating a list works in Python. First, we create a list using a pair of square brackets. This creates an empty list that is a list with no elements. In an empty list, there are no elements at position 0. Trying to access such an element generates an error. To add an element at the end of a list, we use the method append and apply it to the object, referenced by the variable marks. The syntax in Python is the name of the variable dot the name of the method, followed by round brackets. Within the round bracket, you may or may not have a series of values called argument or parameter of the method. A common error is to forget to add the round brackets after the name of the method. This does not create a syntax error in Python. It means something entirely different to what you meant. In our example, we add the integer 60 at the end of the list, marks, by using the command marks.append open round bracket 60 close round bracket. 60 is added at the end of the empty list and becomes the first and only element of the list. We can add more elements using the append method multiple times. The elements do not need to be of the same type. Here we add a float at the end of the list marks. The next statement calls the print method on the list marks. When doing so, the interpreter looks for variable name mark in the namespace, and if found, prints the element one by one. The following statement calls the print function again, but this time on a single element of the list. To get a single element of a list, use the name of the list, followed by square brackets, and within the square bracket is the position of the element to fetch. Remember, position 1 represents the second element in the list, which is 80 in our example. Be careful. If you try to print an element at index 3, the interpreter generates an error, as the last element is at position 2. We have seen how to read a value at a given index in a list. We should be able to modify the list at a given index too. This is done using the assignment operator. The right-hand side of the operator is evaluated first. On the left-hand side, the interpreter looks for the element at a given index. This is done by using the name of the variable followed by the index of the element to be changed between square brackets. The assignment operator assigns 60 to the third element of the list marks. It is very important to remember methods available for a given data structure. We have seen append, a method which adds an object at the end of the list. But there are more. For example, clear removes all items from a list. Count returns the number of an occurrence of a given value. Extend list by appending elements from an iterable, like another list. Index returns the index of a given value. Insert a given object before index. Pop remove and return the item at a given index, and the default is the last element. Remove the first occurrence of a given value. To know more about the different methods, you should refer to the documentation. In addition to knowing the method, it is important to know about their performances. Let's consider the method pop, which removes an element from a list. Given a list data of more than 100 values, in the interpreter we'll be calling pop in two different ways. First, we call pop without any parameters. This removes the last element of a list. The interpreter gets the last element of the list and removes it directly. This is very simple and efficient operation. In computer science terms, we say the operation is done in constant time. That is, the efficiency of the operation does not depend on the size of the list. Here we've got a list containing hundreds of elements. It's going to be done very quickly. And if you got a list of 1,000,000 elements, it will be done as quickly. Now let's call the method pop, but this time with one argument, 0. This call tells the interpreter to remove the first element of the list. Once the value has been removed, we are left with an empty space at index 0. This is not a valid state, as 23 should be the first element of the list. So the value 23 is moved to the index 0. Unfortunately, we didn't fix the problem. We just shifted it to position 1. So we need to do the same thing again and again, until we arrive at the last element of the list. The last place in the list is empty and it can be discarded. Counting the number of shifting operations done in the process, it is almost equal to the size of the list. If we have a list containing 100 elements, we need to shift values around 100 times. If we have 1,000,000 values in the list, we need to shift around 1,000,000 values. It is clear this is not as efficient as the previous operation. We say the pop method is done in linear time. That is, it is proportional to the size of the list. The larger the list, the longer it takes to complete the operation. Later in the term, we'll be looking at an alternative implementation of a list that is more efficient at removing its first element. What about the insert method? Is it efficient or not? This is a question you should try to answer by yourself. To iterate through a list, we get the first element, do some processing, then go to the next element, do some more processing, and so on. It is clear that iterating through a list is a job that should be done using a loop. There are two common ways to iterate through an entire list. A for loop is usually preferred to a while loop. When a program iterates through a list, it knows exactly how many iterations it needs. If the size of the list is n, to go through the entire list, we need to do n iteration, one for each element of the list. It's a kind of count control loop. Let's look at the first example. Mark is a list containing 4 elements. The header of the loop contains the keyword for as well as the keyword in. This statement means that the variable grade will take the value 60 for the first iteration, then 80 for the second iteration, and so on. Therefore, the for loop will print the 4 marks on a separate lines. In the second example, we have a more familiar form of the for loop using the range function. The parameter of the range function is len, open round bracket, marks, close round bracket. The function len returns the size of the list marks. The variable index, which is our counter, will take the value 0, then 1, 2, and finally 3. The code on the left-hand side is useful when you want to read the content of a list without modifying it, or where the index of an element in the list does not matter for the process. On the other hand, the code on the right-hand side is useful when values in the list need to be modified, or when the position of an element in a list matters for the process within the loop. I said earlier that a for loop is preferred to while loop when traversing a list. However, if you are unsure that you need to traverse the entire list, you may want to use a while loop instead. In this example, we want to traverse the list and print the mark as long as the data in the list is valid. That is, as long as the mark is positive. We can see that the third element in the list is not valid, as -60 is not a valid mark. The process should stop before the end of the list. When using the while loop, you need a variable to represent the index of an element in the list. In our example, the variable is called index. We initialize index to 0, the position of the first element. Finally, in the body of the loop, we must have a statement to increase the index. If this statement is omitted, the program will enter an infinite loop. Note also the condition where we check that the index is strictly less than the length of the list of marks. In this video, we have seen one of the built-in data structures provided by Python to represent a collection of objects. You will find some similarities with two other data structures, tuple and sets.